August 1941. The North Atlantic stretches gray and hostile beneath a Royal Air Force Hudson bomber. Squadron leader James Thompson scans the endless waves through his cockpit glass. Visibility is poor. Cloud cover sits low. Then, breaking the surface 300 meters below, a dark shape emerges from the deep. A German U-boat. She has just surfaced, her conning tower crew scrambling to man positions. Thompson does not hesitate. He pushes the throttle forward and dives. Depth charges tumble from the aircraft's belly, bracketing the submarine in towering geysers of white water. Inside that steel hull, chaos erupts. Lights fail. Instruments shatter. Water begins pouring in. The crew, most of them young sailors on their very first patrol, freeze in terror. They can smell something worse than seawater, chlorine gas. The batteries have cracked. Their captain, Kapitänleutnant Hans-Joachim Ramlow, faces an impossible choice: dive into certain death or surrender the boat intact to the enemy. What happens next will change submarine warfare forever. If you are watching this channel for the first time, take a moment to subscribe and leave a comment telling us where you are watching from. Now let us return to that gray morning in the North Atlantic, where a single German submarine was about to hand the British their greatest intelligence prize of the war. U-570 was a Type 7C submarine, the workhorse of the German U-boat fleet. She had been commissioned only months before, in May of 1941, under the command of Ramlow, a young but experienced officer. Her crew numbered 43 men. Most were green, fresh from training schools, their stomachs still adjusting to the constant roll of the ocean. The air inside the boat was foul from the start. Diesel fumes mixed with human sweat. The ventilation could barely keep up. When they submerged, the atmosphere grew worse. Men breathed recycled air, thick with carbon dioxide, while condensation dripped from every surface. This was life inside a Type 7C, cramped, uncomfortable, unforgiving. The patrol had gone badly from the beginning. Rough seas had battered the crew. Equipment malfunctions plagued them. The hydrophones, those sensitive listening devices that allowed U-boats to detect enemy ships, had been damaged early in the voyage. Without them, the submarine was partially deaf, forced to rely on visual observation alone. Ramlow had surfaced that August morning to recharge batteries and refresh the poisonous air below. He had not conducted a proper periscope search before giving the order to surface. It was a mistake that would cost Germany an entire submarine and provide the Royal Navy with secrets worth more than gold. Thompson's depth charges did not sink U-570. They did not need to. The explosions were close enough to wreak havoc inside the pressure hull. When Ramlow assessed the damage, the situation looked catastrophic. The bow was taking water. Battery cells had cracked, releasing chlorine gas into the forward compartments. The crew was panicking, many of them convinced they were about to die. Some began crying, others prayed. The submarine's own torpedoes sat in their tubes, armed and dangerous, adding another layer of fear. In those desperate moments, Ramlow made his decision. He ordered a white sheet brought to the conning tower. U-570 surrendered. The British barely believed their luck. A Type 7C, intact, floating on the surface with most of her crew still alive. This had never happened before. Previous U-boat captures had yielded only wreckage and bodies. But here was a complete submarine, her engines still functional, her instruments still readable, her secrets still hidden within her steel skin. Thompson circled above, keeping watch, while urgent radio messages flashed back to Coastal Command. Within hours, an armed trawler, a Catalina flying boat, and several Royal Navy vessels converged on the scene. The race was on to secure the prize before it sank, or before the crew could scuttle it. The salvage operation proved harrowing. Rough weather threatened to swamp the listing submarine. British sailors from the trawler Northern Chief boarded the U-boat, working alongside terrified German prisoners to pump out water and stabilize the hull. At one point, the submarine nearly capsized, nearly taking her captors with her. But the British refused to let go. They had glimpsed what was inside. They understood that this submarine represented something more valuable than any cargo or prisoner. She represented knowledge. German engineering laid bare for examination. Towed slowly toward Iceland, U-570 finally reached port in Thorlakshofen on August 30th, 1941. There, British intelligence officers swarmed aboard. They photographed everything. They measured everything. They cataloged every piece of equipment, every fitting, every modification. And what they discovered inside that cramped hull would fundamentally alter how they understood submarine warfare. The British had been fighting U-boats since the war began. Their primary weapon was ASDIC, an early form of sonar that sent acoustic pulses through the water and listened for echoes bouncing off submerged objects. When ASDIC pinged against a submarine hull, trained operators could determine range and direction. Surface escorts would then race to drop depth charges. It was an effective system, but it had limitations. ASDIC worked best against submarines that were noisy, submarines that made sounds, submarines whose machinery hummed and clanked and gave away their positions. The British assumed all submarines made such noise because their own submarines did. Royal Navy boats were loud. Crews could hear pumps running, motors whining, metal clanging against metal. It was accepted as inevitable. Submarines were machines, and machines made noise. What the British found inside U-570 shattered that assumption. The Germans had not accepted noise as inevitable. They had declared war on it. And they had been winning that war for years before the British even knew it was being fought. Inside U-570, British engineers found rubber everywhere, not just in the obvious places like seals and gaskets, but in places no British submarine designer would have thought to put it. Every auxiliary machine sat on resilient rubber mounts. Every instrument panel floated on rubber dampers. Every switch, every contactor, every gauge rested on small rubber-bounded units that isolated them from the hull. The consistency was staggering. Large equipment and small equipment alike received the same treatment. Nothing touched the hull directly, if it could possibly be cushioned. The engineering report noted how impressive this systematic approach was. Almost every piece of machinery had been mounted on rubber. The attention to detail extended to the most minor components. A light switch would have rubber mounting. A pressure gauge would have rubber mounting. A ventilation fan, a pump, a motor, all cushioned, all isolated, all designed to prevent vibrations from traveling through the metal structure of the boat. British engineers initially theorized that this was protection against depth-charge shock. Explosions nearby could jar equipment loose, crack instruments, knock out critical systems. Rubber mounts might keep delicate apparatus safe during attacks. This explanation made sense to a point, but it did not explain why every single fitting required such protection. Some equipment aboard British submarines survived depth-charge attacks perfectly well without resilient mounting. Why would the Germans go to such extreme lengths for items that did not need shock protection? The answer lay in the water itself. Sound travels through water 4 times faster than through air. A submarine trying to hide must not only stay out of sight, but out of hearing. Every piece of equipment that vibrates, every motor that hums, every pump that cycles, sends acoustic energy into the hull. The hull transmits that energy into the surrounding water. Enemy hydrophones can detect those sounds at considerable distances. A submarine does not need to have its propellers thrashing to be heard. A noisy bilge pump can betray its position. A rattling fan can announce its presence. The Germans understood this. The British apparently did not. The captured U-boat revealed another purpose for all that rubber. The Germans had developed sophisticated hydrophone arrays, far superior to anything mounted on British submarines. These passive listening systems allowed U-boats to detect enemy ships at ranges of up to 20 miles. But hydrophones are extremely sensitive to local noise. If the submarine itself is humming and clanking, Those sounds drown out the faint signatures of distant targets. The rubber mounting did double duty. It reduced the submarine's acoustic signature, making it harder for enemy sonar to detect, and it reduced internal noise, making the submarine's own hydrophones more effective. German submariners could hear better because they had made themselves quieter. The hydrophone equipment recovered from U-570 astounded British analysts. The German system consisted of arrays of 24 3-inch crystal hydrophones, arranged to provide directional listening. The quality of construction was excellent. The sensitivity was beyond anything in the Royal Navy inventory. When British submarines tried to detect enemy ships using their own hydrophones, they struggled with interference from machinery noise, flow noise from water passing the hull, and 100 other sound sources that contaminated the acoustic picture. German operators faced far fewer problems because German engineers had solved the noise problem at its source. This represented a fundamental philosophical difference between the two navies. British submarine designers had focused on weapons, propulsion, and diving depth. Acoustic stealth had received little attention. The Germans, by contrast, had recognized that silence was survival. A submarine that could not be heard was a submarine that could not be found. A submarine that could not be found was a submarine that could not be killed. Every piece of rubber, every damper, every resilient mount was a small investment in the crew's lives. Collectively, they made the Type 7C one of the quietest submarines in the world. If you are finding this video informative, take a moment to like and subscribe. Your support helps us continue bringing you detailed historical content. The intelligence harvest from U-570 continued for months. The submarine was eventually commissioned into the Royal Navy as HMS Graf, given the pennant number P715, and operated on war patrols until she was damaged beyond economic repair in 1943. But her greatest contribution to the war effort came not from her combat operations, but from the comprehensive analysis of her construction. British engineers did not simply admire German innovation, they copied it. The rubber mounting technology was reverse-engineered and adapted for British submarines. New boats entering service incorporated resilient mounts for auxiliary machinery. Existing boats underwent modifications where practical. The improvement in acoustic stealth was measurable. British submarines became harder to detect, both by enemy sonar and by their own crew's ears when trying to listen for contacts. This was not the only German quieting technology that the British encountered during the war. Deeper secrets lurked in German research laboratories, secrets that would not be fully understood until after the fighting ended. But U-570 cracked open the door. She proved that the Germans were years ahead in acoustic engineering. She provided blueprints for catching up. The man behind much of the German submarine quieting research was Edwin Meyer, an internationally renowned acoustic scientist. Meyer had pioneered the study of vibration isolation and sound damping. His work extended beyond military applications into industrial acoustics and concert hall design. But when the war began, his expertise was directed toward making U-boats silent. The rubber mounting systems found aboard U-570 bore the fingerprints of Meyer's research. Small rubber-bounded units carefully designed to absorb specific frequency ranges, positioned at critical points throughout the submarine. It was applied physics at its finest, theoretical knowledge translated into practical hardware that saved lives. Meyer's work would eventually lead to something even more ambitious than rubber mounts. During the war, German scientists experimented with anika coatings, materials designed to absorb incoming sonar pulses rather than reflect them. This technology, codenamed Alberic after the invisible dwarf from Richard Wagner's opera cycle, represented the next step in submarine stealth. If rubber mounts reduced the noise a submarine made, anechoic coatings reduced the echo it returned. A submarine coated in Alberic tiles would be harder to find both passively and actively. She would be acoustically invisible. The Albrick tiles were manufactured by the chemical giant IG, Farben using a synthetic rubber compound called polyisobutene, marketed under the trade name Opinol. Each tile measured roughly 1 meter square and 4 millimeters thick, actually consisting of two 2-millimeter sheets bonded together. The tiles contained small air cavities and perforations that helped break up incoming sound waves. When properly applied to a submarine hull, the coating could reduce sonar echoes by approximately 15% in the 10 to 18 kHz range. This might not sound dramatic, but in the acoustic realm of submarine warfare, 15% could mean the difference between detection and escape. Development began in 1940 with early trials conducted on U-11, a small Type II training submarine. The results were promising enough to warrant larger-scale testing. U-67, a Type 9C boat, became the first operational submarine fitted with Albrick coating. She put to sea with her hull sheathed in synthetic rubber, a strange vessel that must have looked peculiar in dry dock. But problems emerged almost immediately. The adhesive bonding the tiles to the steel hull proved unreliable. Seawater penetrated the joints. Tiles peeled away during operations. Water pressure at depth compressed the air cavities, reducing effectiveness. Maintenance crews found sheets of rubber floating off into the harbor. After her first patrol, U-67 returned to Wilhelmshaven with significant tile damage. The coating was removed from all parts of the boat except the conning tower and bow. Further experiments continued, but the adhesive problem proved stubborn. Engineers tried different bonding agents, different application techniques, different tile configurations. Each solution brought new complications. The war was rushing forward, and Albrick remained an experimental technology rather than a standard fitting. It was not until 1944 that Albrick finally achieved operational status. U-480, another Type 7C, received a complete coating and deployed on combat patrols. The results were remarkable. Operating in the English Channel, one of the most heavily patrolled waters in the world, U-480 sank 4 ships in her first patrol. She returned safely and departed on a second patrol, again slipping past British defenses. Her acoustic stealth gave her advantages that uncoated submarines lacked. She could approach convoys more closely before being detected. She could evade hunting groups more easily. She could loiter in dangerous waters with greater confidence. The Allies did not capture U-480 intact. She was lost with all hands in February 1945, probably to a mine in the English Channel. Her wreck was not discovered until decades later, but fragmentary intelligence about Albrick reached British analysts during the war. They knew the Germans were experimenting with sonar-absorbing coatings. They knew some submarines had been fitted with the material. They did not fully understand how effective it could be. The anechoic coating technology offered more than stealth against enemy sonar. It also dampened internal engine noise, reducing the sound radiated by the submarine's own machinery. This dual benefit made Albrick doubly valuable. A submarine wearing this rubber skin was harder to find and quieter in operation. The technology represented a synthesis of everything German acoustic engineers had learned since the war began. British scientists took careful note of captured documents describing Albrick. After the war, when Allied teams swept through German naval facilities, they recovered samples of the coating and detailed reports on its performance. This intelligence fed directly into post-war submarine development. The Royal Navy's first nuclear submarines would incorporate anechoic coatings descended from German wartime research. The Americans, who had their own captured U-boats to examine, pursued similar programs. The legacy of Albrick lives on in every modern submarine. Their hulls sheathed in tile systems evolved from that initial German experiment. But in 1941, the immediate prize was U-570 herself. Commissioned as HMS Graf, she served alongside the submarines she had been built to destroy. Her career as a British boat was not distinguished. Mechanical problems plagued her, perhaps unsurprising given the damage sustained during capture and the difficulties of obtaining spare parts for German equipment. British crews found her accommodation uncomfortable, the cramped spaces wearing on morale during extended patrols. But every hour she spent at sea provided additional data on German submarine capabilities. Every trial she underwent revealed new details of her construction. The Royal Navy ran extensive comparative tests between Graf and British submarines of similar size. They measured noise signatures at various speeds and depths. They tested diving capabilities and surface handling. They evaluated the performance of every system against its British equivalent. In most categories, the German boat held her own or exceeded expectations. The hydrophone array consistently outperformed British equipment. The periscope optics were excellent. The main criticism in the official report concerned habitability, poor and cramped crew accommodation that would degrade crew performance on long patrols. British designers may have built noisier submarines, but they treated their crews somewhat better. The testing program also exposed German weaknesses. The Type 7C had limited fuel capacity, restricting patrol duration. Her surface speed was adequate, but not exceptional. The torpedo reload mechanism, while functional, demanded considerable skill and physical strength from the crew. None of these limitations surprised British analysts. They had been sinking Type 7C boats throughout the war and understood their operational characteristics. What surprised them was the sophistication of the acoustic engineering, the systematic approach to noise reduction that permeated the entire design. One particular test illustrated the gap between British and German thinking. Analysts mounted hydrophones inside Graf's hull to measure internal noise levels while various systems operated. They compared these readings to similar measurements from British boats. The difference was striking. Graf generated significantly less acoustic energy even with equivalent equipment running. The rubber mounts absorbed vibrations before they could reach the hull. The careful attention to isolation paid dividends measurable in decibels. British submarines broadcast their presence into the water. German submarines whispered. The war in the Atlantic hung in the balance during 1942 and 1943. German U-boats came agonizingly close to severing Britain's lifeline of supplies crossing from America. Convoy after convoy faced Wolfpack attacks. Merchant ships sank by the hundreds. The tonnage lost seemed unsustainable. Then the tide turned. Allied forces developed new tactics, new technologies, new weapons. Air patrols closed the mid-Atlantic gap. High-frequency direction finding, known as Huff-Duff, allowed escorts to locate transmitting U-boats. Improved radar spotted surfaced submarines at night. Depth charges grew more accurate. Escort carriers provided air cover even far from land. The U-boats began dying in numbers that Dönitz could not replace. German quieting technology could not save the U-boat fleet from this convergence of Allied advantages. No amount of rubber mounting could hide a submarine from radar when it surfaced to recharge batteries. No anechoic coating could prevent detection by aircraft patrolling overhead. The strategies that had made U-boats successful in 1940 and 1941 became liabilities by 1943. Surfacing was suicidal. Transmitting was suicidal. Operating in groups was suicidal. The hunters became the hunted. But the acoustic stealth technologies developed by German engineers retained their relevance. As the war ended, a new era of submarine warfare began. Nuclear propulsion promised vessels that never needed to surface. These boats would spend their entire patrols submerged, invisible to radar, unreachable by aircraft. Detection would depend entirely on sonar, both active and passive. In this underwater environment, acoustic stealth became paramount. The lessons learned from U-570, from the Alberich experiments, from every piece of German submarine technology captured and analyzed, formed the foundation for Cold War submarine development. The British took their knowledge forward into the post-war period. Royal Navy submarines incorporated improved sound isolation. Machinery spaces received acoustic treatment. Crews trained in quiet operating procedures, learning to minimize unnecessary noise. The concepts pioneered in German U-boats became standard practice throughout Western navies. Silence was survival, a lesson written in the captured blueprints of Type 7C submarines. Take a moment now to subscribe if you have not already, and consider supporting the channel so we can continue bringing you these in-depth historical explorations. Your engagement makes a real difference. The story of submarine quieting did not end with the German surrender. It accelerated. The United States Navy had its own captured U-boats to examine, including advanced Type 21 boats that represented the future of submarine design. These new submarines incorporated everything German engineers had learned during the war. They were faster underwater than on the surface. They had streamlined hulls. They carried improved batteries that extended submerged endurance. And they were quiet, incorporating all the acoustic isolation techniques developed over years of combat. The Type 21 threatened to revolutionize submarine warfare. Had these boats entered service in significant numbers earlier in the war, they might have restored German dominance in the Atlantic. Their speed allowed them to outrun surface escorts. Their endurance allowed them to remain submerged during entire attacks, surfacing only far from danger. Their acoustic characteristics allowed them to listen for targets while remaining undetected themselves. British analysts recognized the threat immediately. Studies warned that existing anti-submarine tactics would be ineffective against such vessels. New countermeasures were needed. U-2511, a Type 21 submarine, was captured intact at the end of the war and taken to the United States for evaluation. American engineers conducted exhaustive tests, measuring every aspect of her performance. The submarine demonstrated capabilities that exceeded anything in the Allied inventory. She could dive faster, maneuver better, and run quieter than any American boat. The evaluation team recommended extensive reverse engineering. Within years, American submarine design had incorporated lessons learned from the captured German boats. The Cold War transformed submarines from commerce raiders into strategic weapons platforms. Nuclear missiles gave submarines the ability to strike targets thousands of miles inland. Nuclear propulsion gave them virtually unlimited endurance. But stealth remained critical. A submarine that could be found could be killed, and a killed submarine could not launch its missiles. The entire strategic deterrent depended on submarines remaining hidden, and remaining hidden depended on remaining quiet. Soviet submarines proved notably noisy during the early Cold War period. Their propulsion systems generated considerable acoustic signatures. Western navies developed extensive capabilities to track and monitor Soviet boats using networks of hydrophones seeded across ocean bottoms. American attack submarines shadowed Soviet ballistic missile submarines, maintaining constant contact, ready to neutralize them should war begin. The Soviets, in turn, worked desperately to quiet their fleet, eventually achieving parity with Western designs. Through all this development, the fundamental principles established during World War II remained valid. Isolate machinery from the hull, use resilient mounts, minimize rattling and clanking, apply sound-absorbing coatings, train crews to operate quietly. The German engineers who filled U-570 with rubber mounts would recognize the philosophy guiding modern submarine construction. They had understood the physics of underwater acoustics decades before the technology existed to fully exploit their insights. HMS Graf herself met an inglorious end. After her service career concluded, she was damaged beyond repair and ultimately expended as a target. No physical traces of the captured submarine remain. But her influence persists in every quiet submarine patrolling the world's oceans. The Royal Navy learned from her secrets. So did the United States Navy and every other naval power that studied German submarine technology. the knowledge extracted from her steel hull shaped 60 years of development. The men who served aboard U-570 survived the war. Kapitän-Leutnant Ramlow faced criticism from fellow Germans for surrendering his boat rather than scuttling it. The decision haunted him. Other U-boat commanders had chosen death over capture, taking their crews and their secrets to the bottom. Ramlow had chosen life for his men, and in doing so, handed the enemy a treasure trove of intelligence. Whether he made the right choice depends on perspective. His crew lived. His boat taught the enemy how to kill more German submarines. The calculus of war rarely offers clean answers. The acoustic scientists and engineers who developed U-boat quieting technology also survived, most of them. Edwin Meyer continued his work after the war, contributing to civilian acoustic research. Other specialists were recruited by Allied nations eager to tap their expertise. The flow of German engineering talent into Western defense programs shaped everything from rockets to submarines to jet aircraft. Science has no nationality when victory is at stake. Looking back across 8 decades, the capture of U-570 appears as a pivotal moment, though its significance was not immediately apparent. At the time, British authorities celebrated the intelligence coup, but kept details classified. The public knew that a submarine had surrendered, a propaganda victory in itself. They did not know what the British had found inside. The rubber mounts, the hydrophone arrays, the systematic approach to noise reduction all remained secrets, too valuable to reveal even in celebration. The broader lesson transcends submarines. Technology flows between adversaries during war. Each side studies captured equipment, analyzes wreckage, interrogates prisoners. The best innovations rarely stay exclusive for long. German engineers developed rubber mounting and anechoic coatings. British and American engineers copied and improved upon them. Soviet engineers, through their own intelligence operations, eventually acquired similar knowledge. The cycle continues today, with nations racing to develop advantages that their rivals will inevitably duplicate. Underwater warfare remains dominated by acoustics. Modern submarines carry sophisticated sonar systems that can detect targets at enormous ranges. They also employ elaborate quieting measures to avoid detection themselves. Pump jets have replaced propellers on many boats, eliminating one of the primary sources of noise. Anechoic coatings cover hulls in rubberized tiles that absorb incoming sonar pulses. Machinery floats on rafted decks, isolated from the pressure hull. The principles are the same as those found aboard U-570. The implementation has simply grown more refined. One of the fascinating aspects of this history is how much was learned from a single captured submarine. U-570 was not special within the German fleet. She was a standard Type 7C, one of hundreds. Her construction reflected standard German practices, standard German engineering, standard German attention to acoustic detail. The British did not need to capture a prototype or an experimental boat. Any U-boat would have revealed the same secrets. The Germans had simply not expected to lose one intact. This raises questions about security and overconfidence. The German Navy assumed their submarines would either return safely or be destroyed beyond recovery. They did not plan for capture. Critical documents were not kept properly secured. Equipment was not rigged for rapid destruction. When Ramlow surrendered, his boat retained most of her secrets. A more paranoid Navy might have installed scuttling charges that the captain could trigger instantly. A more thorough training program might have instructed crews to destroy sensitive equipment before capture. The Germans failed to anticipate the scenario that actually occurred. The British, to their credit, exploited the opportunity brilliantly. Teams of specialists descended on the captured submarine with methodical thoroughness. They did not rush. They did not overlook minor details. They understood that knowledge is cumulative that small insights combine into large advantages. The reports generated from U-570's examination filled hundreds of pages, copies circulated to shipyards, to research laboratories, to submarine commanders. The entire Royal Navy Submarine Service benefited from one aircraft crew's lucky encounter on an August morning. Similar intelligence coups occurred throughout the war. Enigma machines were captured from U-boats, breaking open German communications. Radar equipment was recovered from downed aircraft, revealing enemy frequencies and capabilities. V-weapons were examined after landing on British soil, providing data for countermeasures and eventually for Allied rocket programs. Each capture added pieces to the puzzle. Each analysis improved understanding of enemy capabilities. The war was fought with bullets and bombs, but it was also fought with knowledge. The U-boat war specifically generated enormous intelligence efforts on both sides. The Germans tried to understand Allied sonar and radar. The Allies tried to understand German torpedoes and submarine designs. Both sides intercepted communications and analyzed traffic patterns. Both sides developed countermeasures to enemy countermeasures, an endless cycle of adaptation. Into this contest, the capture of U-570 dropped like a gift from heaven. Suddenly, the British had answers to questions they had been asking for years. They knew how German submarines achieved their acoustic performance. They knew what technologies to prioritize. They knew where their own designs fell short. The specific innovations copied from U-570 included the rubber mounting systems, the sound-powered telephone installations, the broadcast system design, and various instrument isolation techniques. British reports noted how every instrument, whether large or small, received resilient mounting with impressive consistency. This systematic approach was itself a lesson. Quieting a submarine required attention to every detail, not just the major machinery. A single rattling gauge could compromise an otherwise silent boat. Training materials were updated to reflect the new understanding. Submarine crews learned why noise discipline mattered. They learned that dropping a wrench could travel through the hull and betray their position to enemy listeners. They learned to move carefully, speak softly, operate equipment gently. The human element complemented the engineering improvements. Technology and behavior combined to create quieter submarines. The German crew of U-570 could not have known what they were surrendering. To them, the submarine was simply their home, a complex machine they had learned to operate. They knew she was well built. They knew her hydrophones were excellent. They probably did not realize how far ahead German acoustic engineering had progressed compared to the enemy. That knowledge resided in research facilities and engineering offices, not in the minds of common sailors. Romlo himself may have understood more, but he faced impossible circumstances. Chlorine gas was filling his boat. His crew was panicking. Diving meant certain death. He chose to live. History does not record whether Romlo ever learned what his surrender cost Germany. The intelligence extracted from U-570 contributed in ways impossible to quantify to the eventual Allied victory in the Atlantic. More U-boats were sunk because British submarines became quieter, because British tactics improved, because British engineers understood their enemy better. Lives were saved on Allied ships that might otherwise have been torpedoed. Lives were lost on German submarines that might otherwise have escaped. The scales of war do not balance neatly. The broader arc of submarine development stretched beyond the war into an uncertain future. Nuclear submarines carrying ballistic missiles became central to Cold War deterrence. These vessels needed to remain hidden for months at a time, constantly ready to launch weapons that could destroy cities. Acoustic stealth was not merely advantageous, but essential. A detectable submarine was a failed submarine. The rubber mounts and anechoic coatings pioneered by German engineers became the ancestors of technologies that prevented nuclear war by ensuring mutual vulnerability. Ironically, Weapons designed to destroy became instruments of peace, their deterrent value dependent on remaining invisible. Today, submarine forces around the world continue the quest for silence. New materials promise better sound absorption. New propulsion systems generate less noise. New hull designs reduce flow turbulence. Each generation of submarines is quieter than the last. The ocean has become a realm of whispers, where detection margins shrink and stealth technologies grow ever more sophisticated. The story that began with a young German captain surrendering his boat on a stormy August morning continues today in shipyards and laboratories around the world. U-570 is gone, her steel long since recycled. But her legacy persists in every quiet submarine gliding through dark waters, in every rubber mount absorbing vibrations, in every anechoic tile swallowing sonar pulses. The British engineers who examined that captured U-boat 80 years ago would recognize the principles at work. They would understand that silence remains survival, just as it was in the gray Atlantic of 1941. That is the end of our journey today. If you enjoyed this deep dive into submarine history, make sure to subscribe and click the notification bell so you never miss our upcoming videos. Leave a comment sharing your thoughts on this remarkable story of captured technology and wartime innovation. Until next time, fair winds and following seas.